Section 8.4 is graphing f of x equals a times the quantity x minus h squared plus k, which is the graphing form of a quadratic function or problem. For your learning targets, you will be able to identify even and odd functions. You will be able to graph quadratic functions in the form f of x equals a times x minus h, the quantity squared, as well as f of x equals a times x minus h, the quantity squared plus k. So first, for the core concepts, we're looking at our even and our odd functions. So when you're determining if a function is even or odd, you're plugging in negative x into the x values of the equation and simplifying it. If you get back the original f of x, then the equation is even. If you get back the opposite of f of x, meaning every sign has changed, then your function is odd. Additionally, we're going to start looking at another transformation. So that's when we have x minus h, the quantity squared. So notice in the formula, you have a negative here. So it's going to be the opposite. So if I have x minus h, I'm actually going to be going to the right. So x minus h, the quantity squared, means that you're going to the right. And then if we have x plus h, the quantity squared, that means that we're going to the left by whatever the h value is. So for example 1, we're determining if each function is even, odd, or neither. So to do this, we're replacing the x with negative x. So we have 3 times negative x. So this is going to simplify it to negative 3x. So now we compare it back to the original equation. This is not the same. However, I have a positive 3x and a negative 3x. And so since these are opposites, that means this equation is odd. So now looking at B, we're going to plug in negative x. So I have negative x, 2 times negative x squared minus 6. So negative x squared, negative times a negative becomes positive, and I bring down that negative 6. So now I compare it back to the original, and I have the same thing again. So this equation is even. And then our last one, again, we're plugging in negative x. So we have 3 times negative x squared minus 2 times negative x plus 4. Again, negative x squared becomes positive x squared. So we have 3x squared. Negative 2x times negative x is plus 2x. And then I bring down my plus 4. So now when I compare it back to the original, my 3x squared stayed the same, but my negative 2x became positive 2x. So this new equation is not the same thing as the original, nor is it the opposite, because not all of the signs changed. So this last one is neither. So here's, again, the information that was kind of briefly shown to you in the core concept. So again, when I have x minus h, that means that I'm going to be going to the right. When I have x plus h, that means I'm going to be going to the left. Again, this is your vertex form, and what's nice about this is that your vertex is hk, so it's given to you in this equation. And then you should also note that your axis of symmetry is the h value that you pull from the equation, which is also the h value or the x value of your vertex. So for example 2, we're graphing y equals a times x minus h, the quantity squared. So we're going to graph this as well as compare it to the parent function f of x equals x squared. So when I look at this equation, I have this 1/2 in the front. which we've already learned about. So this is a vertical shrink by a factor of 1/2. The new part is looking in here. So I have x plus 2, the quantity squared. So this is going to be a translation left 2. So remember I said it kind of seems like you're doing the opposite because in the original formula, you have this negative. So we are going to actually be going to the left 2. So these are those two transformations. So when I pull out my h and my k is here, and then out here would be my k. I don't have a k in this case. So when we identify our vertex, we're doing the opposite of h. So this is going to be -2. And since I don't have a k value, that means my k value is 0. So I'm going to go ahead and copy that over into my table. And we always want to put our vertex in the middle of the table. So here's my vertex at -2, 0. And then I'm going to do two numbers above and below. So I have -3, -4, -1, and 0. So the x value of your vertex also gives you your axis of symmetry. So again, our axis of symmetry is going to be at -2. So here's your axis of symmetry. Then we need to calculate our values here. So we're going to be plugging in -1 and 0 into our equation here. So when I plug in -1 for x, I'm starting with simplifying inside the parentheses. So I have -1 plus 2, which is going to give me 1. 1 squared is 1. And then 1 times 1/2 is 1/2, or 0.5. And again, we're going to mirror that across. Then I'm going to plug in 0. 0 plus 2 is 2. 2 squared is 4. 1/2 times 4 is 2. So I'm going to plug that value in and mirror that across. So now we can plot our points and draw our graph. So here is our graph of this function. Example 3 now is graphing a times x minus h, the quantity squared, plus k. So we're adding back in that transformation up or down. So first we're going to make our comparison. So I have a negative here, which means that we have a reflection in the x-axis. Then we have the 3. So the 3 is a vertical stretch. By a factor of 3. Then we have this first plus 2 and this second plus 2. So the first plus 2 gives us a translation left 2. And the second plus 2 gives us a translation up 2. So these are all of our transformations shown in that equation. So now we're going to go ahead and make our table. We want to identify our vertex, which is our h and our k, which is both of those plus 2s. So for the h, we do the opposite. So this is going to give us -2, and then our k value stays the same. So we have -2, 2. So then we're going to plug in -3, -4, as well as -1 and 0. So when you plug in -1, -1 plus 2 is 1. 1 squared is 1. 1 times -3 is -3. And then -3 plus 2 is -1. And we're going to mirror that point across. Then we plug in 0. 0 plus 2 is 2. 2 squared is 4. 4 times -3 is -12. And -12 plus 2 is going to give us -10. And then we're going to mirror that value across. So now we can plot our points and draw our parabola. And here is your graph. And note the axis of symmetry is also here at -2. So for this last one, we're transforming a transformed graph. So if you look, this is the same equation that we just worked with in the previous problem. So I'm going to go ahead and copy the graph from the last problem into our coordinate plane here. So here's our graph. So now we're looking at the transformation here. So this transformation in the parentheses of doing x minus 4 means that we are translating this to the right 4. So what that means is we're going to take each one of these points and move them to the right 4 units. So here's this one, 1, 2, 3, 4. So I've moved this one to the right 4 units. And then keep going for each point, moving it to the right 4 units. And then you can draw in your new graph that is translated from the translated graph. So our f of x here is shown in red.